So don't get too hung up on the units because as far as X-ray is concerned, they are the same. Right? Radiation emitting factor of 1. So gray, sieverts, they're the same as far as X-rays go.
0.25 and 2
So 0.25 for depressed, 2 for almost complete destruction of the stem cell numbers. But sieverts, grays, that unit doesn't matter. Reagan, did you have a question? I thought I saw your hand. I thought I saw your hand. Yeah? Okay. Any other questions? All right, in that case, our next topic, right, and this is a familiar one, lethal dose.
Lethal dose.
That's right. So, just a review of last chapter, right? Because we talked about lethal dose already.
Mm-hmm.
So, lethal dose, right? 2 numbers. First number is percentage of people that are going to die. Second number is how long it takes. Right? So we're saying 50% of the population will die within 30 days. Okay. So whatever dose of radiation that is, that would be described as lethal dose, 50-30. Okay. We find out that's around 3 to 4 grays without medical support. Okay. Now, of course, if there is medical intervention, then more people are going to survive. So then you would need a much higher dose to hit lethal dose 50-30. So this over here, we have a survival curve. Okay. So x-axis, dose, y-axis, percentage of population that survives. And as you notice, does this curve start at the corner?
No.
No. So how do we describe this kind of curve? Threshold. And then the curvy means non-linear, right? So these are non-linear, but they are threshold. Okay. So starting at around 1 gray, we start to see some members of the population die. As the dose increases, we see more and more and more of the population die. And so here's our 50%. And as we see, 50% is here somewhere in between 3 to 4 grays. Okay? Without medical intervention. Yes, go ahead.
So if you were going to like put a definition to like lethal dose,
Yes.
would I say it's a dose
Mhm.
that is a percent of the exposed population, like per a certain amount of time? Would that be a good way
So,
to describe it as like a definition term?
so lethal dose is if I've got 1,000 people, how much dose would I need to give these 1,000 people so that about half of them die within 30 days?
Okay.
That is lethal dose.
Alright.
So if none of these people get medical support, I only need about 3 to 4 grays. About half of them would die within 30 days. The rest might survive a little bit longer, some will survive the rest of the way, right? But within 30 days, half die.
So it's the percentage of population expected to die within the span of time,
Correct.
which is 30 days, correct?
Correct. In this case,
3 to 4 gray without
Correct.
medical support.
correct. Now, if these 1,000 people were all brought to the hospital, then they would all survive a lot longer. And so 3 to 4 grays would no longer be lethal dose 50-30. Right? I would need more dose to still kill off half the population despite receiving medical support. So the lethal dose numbers, they do depend a lot on what population we're talking about. That will tell us how much dose we need. By the way, why is this thing non-linear? Why doesn't this just keep going up?
Because the dose ain't happening yet.
Okay, well, so that'll be the threshold, right? But what about why is it curvy and why is it like flatten out at the end? Why is it
Well,
just?
it's
It's not
100%
equal, it's
lethal
different
after a certain
it's
point.
It's not equal.
Okay, so let's see. I think Jay, what did he say?
So at a certain point, let's say less than 1 gray, it's non-lethal,
Mhm.
and then up to a certain point, it becomes totally lethal, and the point in between is just how drastic that change is.
Good. Right, so why is it flattened out? Because there's no one left to kill. We're at 100%. Right, 100% death. It can't keep going further. You can't kill more than 100% of the population.
So the 50% already dead.
200%.
That's right. So the 50%'s died, the 75%'s died, so 100%'s died. You can't go over 100%, right? If I'm looking at 1,000 people and 1,000 people die, you can't go any further than that. Right? If you add a person, well, now you're at 101, right? But you can't go up over 100%, right? Doesn't work.
So what was your explanation for not being linear?
So why is it not linear? Because here only the weakest people are dying off. Everyone else is healing. Here, okay, bless you. So now we have a more linear region. Okay, so this is more proportional. And then here, even the healthiest people are dying off. So usually when you see these lines have curves, it's because of healing or some other effects, right, that is keeping it from being totally straight. So nowadays, right, lethal dose 50/60, this is the more commonly used dose that we talk about because of medical treatment. Other measures that we have used before, lethal dose 10/30. So what does this mean?
10%.
Right, 10% of the population dies after
30 days.
30 days. Great. Lethal dose 160.
100%.
Right. Everyone's dead after 60 days. Okay.
So does that mean is
Very
that
high
good-
dose.
is that means that is that graph? So 100, but that's 60 days. I'm
The
not
graph
sure.
represents everything.
Because 100.
The graph represents everything.
Sorry.
The graph represents everything. It
One
can
more time.
represent your 50%. It can represent your 100%. It can represent your 10%.
But not 60 days, right? So
This has nothing to do with days.
I see.
This is just dose. So we say that these effects happen over 60 days, or 30 days, or 10 days, however, whatever this data was collected from.
This is for 30 days, right? So
No.
because it's written there, sir.
I mean, yes, but does it say, it doesn't say 30 days anywhere here
It
other
says
than.
there, sir. 50 LD 50 or with
I know,
35
okay, but
days.
if I hit this,
No,
right?
if you hide it, but
If I hide
right now you're
this, is there
presenting.
anything about the graph that tells you it's 30 days?
No, no.
No, exactly, right? The graph
Yes.
itself has nothing to do with 30 days. This graph can be used for any time. It does not have to be for 30 days. This could be a 50/60. This could be 160. This could be 20/10 or 10/30. It doesn't matter how many days. The graph looks the same no matter how many days. The only thing is how many people are dying and at what dose. Okay. So, to get a lethal dose 50/30, then yes, we'll have these dose numbers here, and we'll have this 50 here so that it matches up perfectly, right? But we change these numbers, and then we have, graph is the same shape. All you do is you change these numbers, and you have something completely different. Right. All right. So if we are looking at lethal dose 50/60, how much radiation is required to kill off half the population over 60 days? Well, if the medical treatment is just minimal, it's still around 3 to 4 grays. Right? That's enough to kill off half the population in 2 months. If we have optimal supportive treatment, right, basically everything short of bone marrow transplants, it would take about 5 grays to kill off half the population in 2 months. We add on bone marrow transplants, it takes up to 11 grays to kill off half the population in 2 months. So as you can see, as the quality of medical care increases, right, as our treatments increase, it takes more dose to actually kill people off, which is a good thing. It means that our treatments are working. Does that make sense? Yeah. Yeah.
Yes, it
Yes,
makes
sir.
sense.
Makes sense.
So, repair and recovery. Talking about recovery of cells. Do you remember the oxygen effect? Last chapter. OER. Right. So the more oxygen the cell has, the more damage, right? More oxygenated cells, more damage. Okay. Now, if these cells do somehow survive, right? If they survive their damage, then because there's a lot of oxygen, then they can also repair and recover faster. Okay. Now, as far as damage goes, okay, what we found is that approximately 10% of radiation damage cannot be repaired. Right, so when radiation hits DNA, it's actually highly likely that the damage will be repaired. Right, 90% of all damage is repaired. But that does still mean that 10% of damage cannot be repaired. Right, so of 10 things, right? 9 can recover, right? 1, well, doesn't fix itself. Okay, 1 out of 10, right? 10%. So, definitions. Make sure you know these definitions. Okay. Atrophy, radiodermatitis, desquamation, epilation, mutations, genetic and chromatid aberrations. Make sure you know these definitions. Atrophy, this is not a term that's specific to radiation, right? We see the word atrophy used all over medicine. And what is atrophy?
Shrinkage.
Shrinkage, right? Wasting away, right? Patient's been laying in the bed for 2 months and their muscles have atrophied. The muscles shrink because they haven't been using them. Okay? For example, if you are getting ready to sign up to take the ARRT exam, and you're like, you know what? I'm going to schedule the ARRT exam in August, so I have 2 months to prepare. And then you spend no time during those 2 months preparing. Your knowledge will atrophy.
And it's the fun, really.
Your skills will atrophy.
And what will be
Right?
the
Your skills will
opposite, sir?
shrink.
And if you really work hard, what will be the opposite of atrophy?
Growth? Yeah, growth. Okay. Getting buff, right? That's the opposite of atrophy, getting buff. Okay, so, right, radiation can cause atrophy. Radiodermatitis, we've seen this word a long time ago, all the way back in year 1, I think. Okay, so, what is this? That's right, erythema, reddening of the skin, radiation burns, right? That is radiodermatitis, right? Derm, skin, itis, right? Inflammation. Desquamation, okay, this is a fun word to say, desquamation. So, shedding of the outer layer of the skin. So in the video, we saw that they're trying to use medical tape to hold IVs and it was just coming off because the skin was shedding, right? So that is desquamation. Epilation. Alopecia, hair loss.
Jada Peak.
Yes. So, right?
Keep her name on your
So
book.
hopefully,
Jada Peak.
hopefully I get to keep mine, right?
It
So
doesn't
hopefully
look
not
like
too
it's
much
going
epilation.
anywhere.
Yeah, you got a lot of hair, Mr. Hall.
Yeah.
For now.
For now.
We'll see how
The
these
scatter
few
gonna
weeks
catch up
of
to you.
being temporary director pan out. But when I finish, it's all gonna be great. It's gone. You'll have wrinkles everywhere.
He said, y'all stressed, I'm stressed, we all
You
stressed.
tried it.
That's
Right.
Okay. So, epilation. Okay. Mutations. So we talked about mutations last chapter, right? Changes to a gene or changes to the chromosomes, changes to the DNA. Chromosome and chromatid aberrations, we also talked about these last chapter, right? Chromosome affects both sister chromatids. Chromatid only affects one sister chromatid. So, any questions here? So, everyone understands that we do need to know these terms?
Mm-hmm.
All right, excellent. In that case, let's go ahead and just end class year.
Woo! Look at you, Mr.